we are going to continue from where we stopped, the preparation of standard solutions. And today we are going to discuss how we can prepare 0.1 mole per dm³ of sodium carbonate. That is a base. It's different from preparing an acid. Here, we do not consider the relative density of the substance. Come with me. Now, we are expected to calculate 0.1 mole per dm³ of sodium carbonate. How do we go about this? First, remember that the mass of sodium carbonate is 106 grams, of course, per dm³. Again, know that if you were preparing 1 dm³, or 1 mole per dm³ as the case may be, of sodium carbonate in 1 mole per dm³ is still 106 grams. Alright? But here, we are expected to calculate 0.1 mole of what? Sodium carbonate to enable us to prepare a standard solution. Therefore, we will say 0.1 mole per dm³ of sodium carbonate, okay, of course, in 1 dm³ will give us what? It will give us this. We're going to consider this and this. So we have 0.1 mole per dm³ of sodium carbonate times 106 grams all over what? 1 mole per dm³. Of course, the 1 mole per dm³ is with respect to what? Because this 1 mole, 1 dm³ is same thing as 1000 mils. That is the volumetric flux or the working volume we are going to be using. So with this, the mole per dm³ cancel this mole per dm³. Therefore, we have 0.1 itself times 106 grams all over 1. And this, of course, will give us about 10.8. You will calculate and confirm. About 10.8, of course, grams. Now, this is in grams because we are talking about a base. It's not an acid. Bases are always what? In pellets. Inside a container, in pellets. So you are going to weigh them. But the previous lecture we talked about acid. They are a liquid form. So you are going to measure them in what? In centimeter cubic. So in that case, you are expected to do or use a measuring cylinder. But this is a base. So you weigh them, and that's why our calculation is what? In grams. Therefore, it implies that 0.1 mole sodium carbonate is equivalent to 10.8 grams. So what you need to do now is to do what? Use your electrical weighing balance. Weigh 10.8 grams of the sodium carbonate pellet. Turn it into a beaker. Dissolve it and empty it into a 1 dm³ or a 1000 cm³ what? Volumetric flux. When you do that, rinse the beaker properly to make sure every part of this sodium carbonate is emptied into the beaker. It's emptied rather into the volumetric flux. And then you are going to do what? Add your distilled water to the 1000 watt volumetric flux and raise it until it gets to what? The graduation mark. Shake it and do what? Store it. In that way, you have completely been able to prepare your 0.1 mole sodium carbonate standard solution in the lab for you to use in your experiment. You can prepare also sodium carbonate, which is also this. You can also prepare any type of salt at all that you wish to use. Even if it's sodium sulfate, you can still prepare it using this same format. And at the end of the day, you have been able to prepare successfully your standard solution. This is the way you do it. I'm sure you've learned something again from today's lectures. Remember to share, remember to like, remember to do what? Follow. Go to my YouTube channel, go to my Facebook page, and do that. Till next time, have a nice day.